Hello, and welcome to episode 69 of our Space Engineers Let's Play series. And today we are going to be code reviewing collision detection. Before we get into the code review, though, I will show you a demonstration. We are on the Autopilot FLYTO mission between the SIC and the Space Ice Station waypoint, going at a nice leisurely 20 meters per second. Now that path does include a drive straight through the asteroid that the ice station is planted on, due to the way the asteroid is oriented relative to the space industrial complex. So this will show you that the collision detection is working. Right now we're just doing detection. If we detect a collision, we're going to stop the ship, and we're going to do it in time. At least it works that way so far. In the future, we will try, if I can figure out how to code it up, a collision avoidance algorithm, so that it'll say, hey, there's something in the way here, let me find a way around it, and still ultimately get us to the waypoint that we're aiming for. The trick, I think, is going to be trying to figure out a way to deal with planets and gravity. But you can see it says collision detected on the bottom. It detected an asteroid, and it brought us to a almost complete stop, as much as the Autopilot FLYTO mission ever brings us to a complete stop at this point. And it actually says Autopilot disabled rather than Autopilot complete, because it did not bring us to our desired location. So anyway, that's it in action. Now I'm going to turn around and head back to the SIC, again at a nice leisurely pace. While that's happening, we will go over the code for the collision detection. So instead of using a list here now, this is just a single camera for the forward camera. I decided it didn't make a whole lot of sense to have multiple cameras involved in this this process. So there's just the one, and that is denoted, it's this one, by the way, by Autopilot collision detector being in the custom data. And we'll see it pick that up later. The other addition here, or change here, is the declaration of a myDetectedEntity info variable called colliding entity. And this, because it's outside of any of the functions here, will be preserved in between ticks. So then if we come down here to update Autopilot, we now have find cameras has been added. Start off by creating a temporary list, do all of our work in the filter as usual. If it's not connected to the shuttle, return false. Now this is a trick that I need to copy over to the Uranium Station, because this is a much cleaner way of doing it than the way I'm doing it on the Uranium Station with the pistons, making sure that the elevation pistons are all elevation pistons because they're pointed in the same direction. But if you do the block orientation forward equals the Autopilot controller's orientation forward, in other words, if the forward direction on both blocks is going the same way, then that will be true. So if it's false, return false, because we want the camera to be facing the same direction as the Autopilot controller, namely forward. And this is looking for that custom data. If the block's custom data does not contain, because we've got this exclamation point here, does not contain Autopilot collision detector, return false. Now here I'm doing a little bit of testing, and I don't need this bit either, of the camera stuff. I wanted to keep it in here just to review it, and in case I wanted to use aspects of it later, in particular this bounding box, the hit position, the entity position, stuff like that. But this is not being run at the moment because it's not necessary, for one, and it uses up our scan range, for two. So the way this works, and there are other tutorials that are specifically about this, but since this is what we're doing here, I'll go over this as well. The way this works is that the camera will do a raycast, so it will shoot out basically a laser beam. It's an invisible laser beam. It's really an imaginary laser beam. It's a computerized laser beam. When you turn on Enable Raycast, it allows you to do that, and it takes a lot more power, first of all. So you will notice, yeah, I changed what the comment was, it doesn't really matter. This camera is taking 30 watts. Oh, I disabled it because I didn't recompile things. Oops. and get us back on course here. Um, so you will notice that this is taking 1 kilowatt for this camera that is our collision detecting camera, whereas this one, which is not collision detecting, is only taking 30 watts. And while it is taking that 1 kilowatt, it is gradually increasing its scan range, and it goes up about 30 meters per tick, give or take, based on what I noticed from running this test code here. Because what I told it to do was show me the available scan range out of the raycast distance limit, and I'm guessing this is a server imposed constraint. Since I'm running single player and haven't configured it to do anything, it's -1, meaning it can go as far as you want it to go. So it could theoretically, raycast to the non-existent edge of the universe. So it could go forever depending on what your server settings are, but the available scan range is what really matters, because that, as you send 1 kilowatt into this camera, with enable raycast set to true, this will increase to tell you how far out you can scan, and then once you scan, it goes down by the distance that you scan out. So if the available scan range gets up to 100,000, meaning 100 kilometers, and you tell it to scan out 10 kilometers, then it'll go down to 90, and it'll be able to continue doing that until the available scan range goes below the distance you're trying to scan, and then it won't be able to do it. You also have a cone that you can do the scan in. The cone for cameras is 45 degrees, so you can go 45 degrees to the left, 45 degrees to the right, 45 degrees up, 45 degrees down, and all around in that kind of cone shape that creates. So what we did here in this test, because I was trying to scan the Earth-like planet from the SIC, it's about 107 kilometers to our original Earth-like planet base. So I have it set to 110,000 here, which is 110 kilometers. There's also different ways that you can configure this scan and this raycast thing, so that you can do it by vector to a position. You can do it by vector in a direction at a distance, or you can do it just at a distance, and then here is a pitch and yaw. So we're doing the pitch and yaw because that's the easiest one to do, because we just want to do dead ahead. So that's 0, 0. And this was going out, like I said, 110 kilometers, because that would have gotten us as far as the planet. So can scan tells you basically if available scan range is greater than this number. It's pretty much all this is doing as far as I can tell. Now obviously if you pass in a vector, it's going to do all the vector math for you to figure out, how that aligns with your available scan range. And also if you do a can scan on a vector that is outside of your cone limit, then it'll also return false. So it does a little bit more than that. But if we're just doing this one based on distance, that's pretty much all it's doing, is saying, hey, is that number smaller than this number? Okay, cool. And then when we do the raycast, that's what's actually doing the work. It's, shooting out that imaginary computer laser beam, and whatever it runs into first gets returned as the last detected entity. Now, this last detected entity I have removed because, again, I'm not using this, but it was in my detected entity info, just like that is. And then if last detected entity does not equal null, and the last detected entity is not empty, because if it doesn't hit anything in that distance, it's going to return empty. If it hasn't run yet because it can't scan that far, it's still going to be null because I didn't initialize it to anything. So that's just basically saving us from that. So if it detected something, basically is what this is saying. If it's run once, if it got to this can scan limit at least once, and it found something, then we can echo out the type. An asteroid is an asteroid, a planet is a planet, large grid ships, missiles, meteors, small grid ships, players. You can find all kinds of stuff. There's an enum that tells you all the different types that could be returned here on the API documentation for the My Detected Entity Info data type. Name. Asteroids and planets are very uninteresting. It doesn't tell you Earth-like planet or anything like that. It just calls it planet. So, it doesn't really have a name. But presumably if you shoot it at your own ship, it'll tell you what the name of your ship is. If you shoot it yourself, it'll tell you what your name is. Stuff like that. Hit position is where you made contact, and this is in absolute coordinates. um, world coordinates, where you actually made that collision, the entity's position, so like where is the entity compared to where you hit it, and then there's bounding box, and this is the one that's going to be useful for us when we get into collision avoidance, because it gives you a min vector and a max vector, basically outlining opposite corners of a cube um, that contains the entire entity. So if we find that we're about to hit an asteroid, we can say, okay, well, what's the nearest edge of this bounding box, and then aim for that instead of aiming for where we're aiming, and use that to basically get around whatever it is that we're about to run into. So that's the idea behind that, and we'll probably need to add a little bit of cushion to that just so that we can, make sure we're going all the way around it instead of scraping on the edge. But we'll figure that out when we get to it. That's going to be kind of tricky. First of all, because we got to figure out which edge is the closest to, move towards to get around it, and then, second of all, to make sure that we're actually going around it enough to clear it. So yeah, that's going to be a thing, but that's the API hook into how we're going to do that. The rest of it's just math and calculation and figuring. So that's the plan there. But again, we're not doing any of this because this was all test code. Actual collision detection, just collision detection, is much simpler. So anyway, we return false if it's not on the same, if it's not on the shuttle, if it's not on the same grid, same construct. Return false if it's not pointed the right direction, so that docking camera we have on the bottom here is automatically out. It also doesn't have the Autopilot collision detector note in the custom data, so it wouldn't pick that one up anyway. But if we do have multiple forward-facing cameras on a ship for some reason, we can still use this code because only one of them is going to be denoted as the Autopilot collision detector. And it's going to put all these into this temporary list called cameras. If cameras count equals 1, then save it as the forward camera. If the cameras count is 0 or more than 1, then there's, for some reason, multiple cameras with this note on it, or no cameras with this note on it, or no cameras facing the right direction, or no cameras at all, whatever. We're going to say it found this many cameras, this many collision detecting cameras found. It should be 1. Maybe I could add that to the note, whatever, doesn't matter. Anyway, so this is finding all of our cameras. Now, how to use them. Now, you'll notice that the bit that actually enables the raycasting is inside the comments here. So we're not going to do this all the time. We're not going to be raycasting constantly because it's, 30 times as much power. Yeah, going from 30 watts to 1 kilowatt. I think they did that math right quickly and in public, about 30, a little bit more. It's more power. And that's a waste, so we're not going to do that here. We're going to do that when we're actually doing it, when we're actually needing it, rather. And that is all in the FLYTO mission. And we're doing that down here. I initially had this in the same if block, so it was saying, if the distance is less than the stopping distance plus a margin. I changed the margin, by the way. Since we've got collision detection now, I feel a little bit more comfortable reducing that. Again, I still want to make this into a parameter, kind of long-term plans, but I didn't do it yet. Whatever, get over it. So now we're saying if the distance is, like if we're within the distance of the point that we're shooting for, distance being, how far the ship is from our target, if the distance is less than the stopping distance plus the margin, then we're going to stop and we're going to set the mission to complete. However, if we're on a collision course within that stopping distance, you might guess this is our desired scan range, then we're going to stop and set the mission to disabled. So there's a difference there. Complete means we did what we wanted to do. Disabled means, we stopped, we canceled for some reason. And in this instance, we canceled because we detected a collision. And you notice that it showed up there. That's actually being displayed inside this is collision course method. So we set a threshold. I want the margin for a collision to be a little bit higher than the margin for stopping. And we can tweak these numbers. They can change. But here's where we actually turn on the raycasting for the forward camera. And this will stay on between ticks because we don't turn it off until we go back into the disabled method, which, by the way, I changed. It's right here. We want to make sure that the forward camera is not equal null. So we want to make sure we found the forward camera before we try to disable the raycasting. But this is in the disable autopilot. So when we disable autopilot because we're complete or disabled, it will also turn off the raycasting. Skip that earlier. Sorry about it. So here's where we turn it on. And like I said, it will stay on as it comes through, so it will continue powering up and increasing the scan range, every time it comes through here. as long as this stays on. So if the forward camera can scan the stopping distance plus the threshold, so if we're able to scan out, then reset the colliding entity to the raycast of the stopping distance at 0, 0, again plus the threshold. So dead ahead as far as we can scan out. Well, not as far as we can scan out, rather. Dead ahead, the stopping distance plus a bit, plus a kilometer in this case. And again, we can change that. Whether that number's optimal or not, I don't know. We'll find out. Could tweak it later. Anyway, so if we can scan, set it. If we can't scan, it's just going to pass through here. So if we haven't been able to scan at all yet, then colliding entity is going to equal null. We're going to return false. If we could scan and we didn't find anything, we're still going to return false. And this is, again, something I'm not entirely sure I'm happy with. I might want to set it so that, you know, and we'll have to do, it's more than just a simple tweak to do this, which is why I didn't do it. But if we're not able to scan yet, it's not really safe for us to just be like, oh, screw it, well, there's no collisions then. It's possible that, you know, we've got something directly in front of us, or directly between us and our target that we would run into, but because we haven't saved up enough power in the camera to scan, you know, even directly in front of us yet, this is still null because it hasn't been set. We haven't done the scan, but it's returning false that there's no collision. So it's going to continue going like it doesn't care. So that's a bit of a problem. But as long as you make sure that you're more or less clear of obstacles before you engage the autopilot, it'll be fine. So that's good enough for now. Anyway, so if we haven't done the scan yet, which like I said is a problem, or we haven't found anything, return false. Is collision course is false. We're not on the collision course, so we can skip this. We can continue on, looping through the cycle. On the other hand, if we did find something within this stopping distance plus the threshold, we've already detected a collision. We don't care about the hit position. We don't care about the position of the colliding entity. We don't care about the bounding box, because right now all we're doing is detecting a collision and then stopping. Eventually, instead of just stopping in here, we'll have to, route around it. And we may change this from returning a Boolean to returning the actual entity so that we can, figure it out, or we could figure it out in here, whatever, haven't decided yet. Anyway, so if we do run into something, a collision is detected, add the notice of what kind of thing we're about to collide into to the autopilot status, and then return true. So that's really it. It's pretty simple. Again, I hadn't really played with it before, so I wanted to do it off camera just to make sure I understood it. And I think I've explained, some of the additional functionality here fairly well in terms of, this test code here when we're detecting it, that I have since pulled out. But once you get the hang of it and, kind of know what you're supposed to be doing and how everything works, I think it's pretty straightforward to actually use the raycasting to detect stuff. The other possibility that this opens up is scouting. Since this has basically an unlimited range, we could set it, to 30 kilometers, I guess, some random number like that, and just have it kind of turn in various directions, or have multiple cameras and say, oh, there's an asteroid, and then it can kind of save the entities off into a database and say, okay, well, I found this asteroid, I found this asteroid, I found this asteroid, I found this asteroid, and then it can target them and fly to them. And if we have an ore detector attached to it and a camera, we can use that as kind of a scouting drone, sit ourselves comfortably on the SIC, have it, fly off to an asteroid, let us know that it got there, and then we can check in on it, fly around a little bit, see if we can find any ores, mark any ores that we want to mark, and then, turn it back on so it'll find another asteroid and fly off to that. And it'll keep track of which asteroids it's found, which asteroids it's visited, and because it's all colliding entities. So like an asteroid is an entity. So like even if you're, approaching it from over here, from over here, from over here, wherever you're approaching it from, it's still the same entity. So we'll be able to say, okay, well, we've been to this one already. We don't have to go back. So that's definitely a cool possibility that we'll probably make use of in the future to continue our ore scouting, because, I mean, some of the deposits that we have are eventually going to deplete. Looks like we've detected a collision with a small grid, probably because it, detected a collision with one of the small ships that are attached to the SIC before it detected the SIC itself. But it stopped us a fair distance away from it, at least a kilometer, because that's the threshold. So again, it probably makes sense to reduce this. But then again, maybe not. Maybe we just want to have this a multiplier. So like if our stopping distance is something really small, like it is now. I mean, it's 34 meters because this is a very light ship right now, um, with no cargo in it, and we're only going 20 meters per second. So the stopping distance is very short. So maybe just doubling it, and then if it's got a longer stopping distance, then we'll be able to have more of a cushion. Then again, maybe we only really need 10. And we can just say, okay, well, we managed to just barely avoid a collision. That's fine. I think it's going to make more of a difference once we're actually avoiding collisions rather than just detecting them and stopping. How much cushion do we need to find a safe route around, given the speed that we're going and how far we have to divert our course to get around whatever we're about to run into. But yeah, so there's some decent possibilities here, and I think that was pretty straightforward, and I hope I explained that well enough that everybody understands it. Now I also promised a code review of the changes to the mining station script, because the ice station script that we have, which we now have the ability to connect to because I actually built an antenna on it, go me, was relying on there only being a single elevation piston. So in our uranium station, we actually have 3 elevation pistons, and naturally that will cause a problem if you're only expecting to have 1. You won't be able to utilize most of them, and honestly, we wouldn't even be able to find them based on the way that it worked. We would only be able to find this one originally because of the way the cube grids were set up. So I did make some changes to it to compensate for that. The elevation pistons are now a list, first of all, and I should think fairly obviously. I really don't like the way that this works with these 2 booleans holding the state instead of it just being a string. So I do want to do a little bit more of a dramatic rewrite to this, but I haven't done it yet. So the first thing that we're going to do is we're going to go ahead and stick it in elevation pistons, at least temporarily. But we're going to find the one that is on the exact same cube grid. So because we know that's an elevation piston, and we need that because we want to know which direction it's facing. And this, like I said, this is not the best way to do this. And playing with the cameras, I found a better way. But what this is doing is this is taking the world matrix, so it's getting the world rotation rather than the relative to the grid that it's attached to orientation, and comparing the up vector to the block's up vector. And since it's a vector comparison, when you do equals on vectors, you can pass in this extra parameter here that's called an epsilon. It's basically correcting for floating point errors. Those of you who are super duper familiar with computer programming realize that floating point numbers don't tend to be exactly equal hardly ever, and even just a little bit of wobble will throw them off. But this is close enough. I mean, it's going to be a much bigger diversion if you're comparing radial pistons, for example, to the elevation pistons. So this gets us close enough, and so basically we're saying here, save the orientation of the one elevation piston that we found, and then add them back into this list, because it's the same list really, but we've saved off the orientation now, so we don't need this to remain intact. We saved off this vector, so it's not important that we're overwriting the list. And we're just saying if the block's rotation is equal to the orientation or the rotation that we saved, within that tolerance, then it's another elevation piston. It's facing the same direction, and it's not a radial piston. It needs to be saved as an elevation piston. And then the radial pistons, initially we were just doing if it's not on the same cube grid. However, we have 2 elevation pistons that are also not on the same cube grid now. Want to make sure it's not on the same construct because we're going to allow it. That was also part of it, I think, initially, because we don't want it to pick up pistons attached to the mega miner, for example. That one is not a radial piston, even if it's not facing the same, or is not on the same cube grid as the elevation pistons, or as the programming block. And here's the the trick if it's not an elevation piston. So in the ice station code, we're actually getting the elevation piston after the radial piston. I'd move that up here so that we can just say if it's not an elevation piston, but it's still on the same construct, it's a radial piston. And that's safe enough for now. I don't know that I can think of a situation where that will not be the case. The rotor code is the same, and the display screen is the same. Dealing with storage is the same. Displaying is the same. What did I change here? Oh, okay. This is something I changed. We're using all 3 radial pistons at once. When we were doing this somewhere. Oh, when we were doing it manually, we were just, yeah, it was just manually. It wasn't automated anywhere. But when we were doing it manually, we were just extending one piston at a time and like letting it extend all the way. Here we're doing all of them. We're doing them in concert. And because we're doing them in concert, when we reset, we're resetting it back so that all 3 of them end up extending 1 meter in total. So we're dividing by the number of elevation pistons. And this is hard-coded for now. It probably shouldn't be. This should be the elevation pistons count instead of 3, because they're the same thing. Elevation pistons count is 3 on this construct, but if we redesign it somehow, then this will no longer be correct. That's the same. That's the same. This is all the stuff for when we're done, when we're ready to reset. So this is pulling the pistons back and shutting everything down. I say shutting everything down, but it doesn't look like it's turning anything else off. Yeah, like I said, I'm not really happy with this script altogether. Pause drilling is the same. Update drills is a little bit different. A lot of it is the same as far as dealing with the radial pistons and whatnot, but with the elevation pistons, and we're just doing this by testing one of them since we're doing all of them in concert. We don't need to test all of them. We don't need to go through and say, well, is this one fully extended? Is this one fully extended? If one of them's fully extended, they're all fully extended. We can rely on that. So if the drill's extending and the elevation piston is at its current limit, so like because this goes level by level, it extends the radial pistons out all the way, pulls them back, and then moves down and does it again. So we're saying if the drill is extending and the elevation pistons are at their current max, so if they're at the right level, they're not moving their way down, which is the advancing state. Then we're drilling, and we want to set the piston velocity to move out. This is if the radial piston is at its limit, then we want to retract. We retract faster than we extend. The drill is no longer extending. So this is when we're actually drilling, and this is when we're advancing. So we're going to say if the radial piston is back at its minimum limit, and we've set this to false because we're done retracting. Well, we started retracting, so this is false. We're done retracting because the current position is the minimum limit for the radial pistons, which is what we're looping through here. We're advancing, and we're showing how the radial pistons are doing. And then we're going to say here if the elevation piston max limit is already set to the highest position. So if it's as far out as it can go, then we're resetting now. And that brings us wherever that function, it reset drills. Oh, it does pause the drilling. Okay, when you reset drills, it pauses it, so it turns everything else off. I forgot it did that. So it resets the drills if the elevation pistons are fully extended. Not as far as they're set to go, but fully extended. That's what this highest position is. And then it'll return, so it'll bail. If it's not fully extended, then we're going to go through all of the elevation pistons, and we're going to increment the max limit by 1/3 of a meter, so that because there's 3 of them, it's incrementing it by a meter. And again, this should be the elevation piston count rather than a hard-coded 3, but it's not. Go over it. And then we're going to set drill extending again. And if this is false, then we're retracting. I'm not sure here what oh, yeah, just because if it's at the max limit, it's going to start retracting. If drill extending is false and we haven't changed it before now, then we're still retracting. We're in the process of retracting. We just want to show how far along we are. Otherwise, we are in this part, but we didn't do this, and we've done this already. So drill extending is true, so we don't do that, we do this, we're advancing. But we're not here yet, so we're still advancing. And again, a lot of this is the same, but just a lot of the places where we're dealing with the elevation pistons, now we have to loop through and divide things by 3. That's really the only difference. See, this is not just setting 1 back to 1, this is looping through and using a third. But everything that we do to 1 elevation piston, we're now doing to all 3. So, yep, that's it. Cargo check is the exact same. No changes to that. And that's been used enough places, I don't think I have to review that again. I don't think I changed anything. No, I didn't change anything. But, yep, that is paused now, because it's full. Mostly of stone, but a fair amount of uranium as well. So we'll have to go and pick that up at some point. We've still got some space in the drills. But, again, we don't want to overfill it. So it's better to just stay where we are. And it would be nice if even when it was paused, it would tell us what the position of all the pistons and stuff are. Oh, okay, so the radial pistons are fully extended. Drills are off. Radial pistons are fully extended. And these are less than halfway. So we're shooting for 13 meters. I mean, they're extended as far as they're supposed to extend. But, you know, obviously this goes up to 10, so we'll go to 30 meters altogether, but this is only 13. And the controller knows that, but when it's paused, it doesn't tell us that, and it probably should. So, again, I'm not super happy with this script, but it's good enough. It's functional. It does what it needs to do. And you can see here, and we've been drifting because the way that we have the margins set on the autopilot, it doesn't fully stop us. That's something else that I should update, so that it probably, you know, turns the inertial dampeners on when it stops us, so that we do actually come to a full and complete stop. But as it is, we've been drifting towards the SIC slowly for the last however long it's been since we detected the collision and stopped. But that is that. I have done the demo of the collision detection, I've done the code review of the collision detection, and I did the code review of the changes that we did to the uranium station. So I hope that was interesting and useful to you. In the next episode, we will probably take a break from collision detection just because the next thing we really need to do is collision avoidance, and that's hard. I don't know right now off the top of my head how I'm going to do it, so that's going to involve some figuring. Instead, we have a couple of little things with scripts that we've been kind of putting off, whether it's refactoring the FLYTO command on the autopilot, or dealing with some issues in the refinery priority, or the inventory sorting, like when the assemblers are disassembling, it's still trying to pull all of the components out of the assembler inventory. That needs to be fixed. And there's also a couple of commands that I would like to build into the inventory management so that it will automatically disassemble everything that's in the component storage, and so that it will automatically push everything that's in the component storage out to, you know, a targeted cargo container, you know, namely the welder, or, you know, pull everything back out of the welder and stick it in the SIC component storage and then push it out for disassembly so that we don't have a whole bunch of extra components on board, because we've got that at the moment and I don't like it. We've got, almost half of our inventory here is full, and most of it's extra steel plates, interior plates, small steel tubes. Like, all of this stuff will fully disassemble back into all of its component parts, but it's not going to do it if we don't tell it to. And even if I hit disassemble all on the assemblers right now, it would be trying to pull the inventory back out into here. And I just want it to be cleaner and better organized and work better. So yeah, that's the thing that's going to happen. Like I said, we'll probably do at least some of that stuff next episode, depending on how hard it is. There's also an issue with the scrolling on the inventory listing on the programmable block that actually shows us what we've got in our inventory. I mean, once we're disassembling all of the components, that's probably not going to matter because they won't be long enough. But when it is long enough, when it is taking up too much of the screen, I would like it to scroll correctly, and it's not at the moment. I've tried to fix it a couple of times off camera and haven't really gotten it to do what I want it to do, so I'm going to try to figure that out probably off camera, but then I'll show you how I figured it out and how it's working. But yeah, we'll do all that other stuff, and that'll probably take up enough time for an episode, and then we'll move on to bigger and better things. So subscribe to see all that. Likes, comments, and verbal abuse are welcome. Next building episode, if I can't think of anything else to do, maybe we'll start working on that whole scout ship idea. At least, get something built. And we'll go from there. So, thanks for watching. See you next time. Bye.